let's give the coordinates of each point shown on this graph. I've labeled the points A, B, C, D, E, and F so that we can locate each of them. For point A, starting at the origin, we will count 1, 2, 3, 4, 5 to the left. That gives us a horizontal value of -5. And 1 up, that gives us +1 for the ordinate, the second coordinate. So A is -5, 1. For B, starting the origin, we'll count to the left and down. 1, 2, 3 to the left, and 1, 2 down. So 3 to the left, -3, 2 down, -2. For point C, starting at the origin, we simply go down. But remember, our first coordinate tells us the horizontal distance. To get to point C from the origin, we go no horizontal distance. So the abscissa, the first coordinate, is 0. So for C, we have 0 for the horizontal distance, then 1, 2, 3, 4, 5, -5 for the vertical distance. So 0, -5 for point C. For point D, we count to the right 2 and up 1, coordinates 2, 1. For point E, we count from the origin 1, 2, 3, 4 to the right, and 1, 2, 3 down, 4, and -3 for those coordinates. And for point F, we count 1, 2, 3, 4, 5, 6, 7 to the right, +7, and then 0 up or down. Now I'd like you to do some exercises. 2 types. First, graph the points. Copy these coordinates down so you can graph these points. For point A, -2, 4. For point B, 0, 3. And for point C, 5, -1. Then, give the coordinates of each point. We have D, E, F, and G. From the origin, 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 down. That should give you enough to be able to count the values for each of these points, D, E, F, and G. Be sure you've got them accurately copied. Then stop the tape, work the problems, restart the tape, and check your answers. Here are the answers. Points A, B, and C on your grid should be located as these are. And for the points you are to identify, D has coordinates -4, -2. E is -2, 4. F is 3, -3. And G is 4, 0. If you made mistakes and can't find where your mistakes are, be sure to get help. Let's look now at a definition. A solution of an equation in 2 variables is an ordered pair x, y that makes the equation true. A solution of an equation in 2 variables is an ordered pair x, y that makes the equation true. When we have 2 variables, it'll take 2 numbers to name a solution. So the key things here are we have two variables, and so it takes values for both x and y to make the equation true. Let's take a look at an example. First, is negative 2, 3 a solution of 3x minus y equals 4? Notice that we have an ordered pair, negative 2, 3. The ordered pair is in the form x, y, which means the negative 2 is the x value, and the 3 is the y value. Our tradition is to make these numbers come in alphabetical order as far as the variables are concerned. To check this, we check just the way we ordinarily check an equation. We copy the equation, then draw a line below it and a vertical line below that so that we can check the two sides of the equation. Well, we have 3 times the x value, which is negative 2, subtract the y value, which is 3. On the right hand side, just 4. Then we work out the algebra. 3 times negative 2 is negative 6. Subtract 3 is negative 6 subtract 3, or negative 6 add negative 3. And that gives us negative 9 on the left, 4 on the right. These are not the same, and so the answer is no. No, this ordered pair is not a solution of the equation. Another type of question dealing with solutions is this. Find the solution of y equals negative 3x plus 2 that has abscissa 4. Remember that the abscissa is the first coordinate, which means abscissa is the x coordinate, and that means the 4 stands for an x value. Then this gives us y equals negative 3x. The x value is 4. So y equals negative 3 times 4 plus 2, which is negative 12 plus 2, which is negative 10. So the solution of the equation is 4 for the abscissa and negative 10 for the ordinate. Our solution is 4, negative 10. So when we're given one portion of the ordered pair, we can simply substitute in and solve for the other portion. To put this technique to use, let's graph the ordered pair solutions of this equation, y equals 2/3 x subtract 1. Graph the ordered pair solutions of y equals 2/3 x subtract 1 for x equals negative 3, 0, 3, and 6. 4 different x values. Well, we'll treat them one by one. To organize the work, let's make a table of values. Our table of values will have x and y. We'll be working with y equals 2/3, fill in the x value, subtract 1. The first x value we want is negative 3. So let's fill in negative 3 in place of x. So for the x value of negative 3, we work out y is equal to 2/3 times negative 3 subtract 1. Well, 2/3 times negative 3 is negative 6 over 3, which is negative 2, and negative 2 subtract 1 is negative 3. So the y value is negative 3. That's a bit unusual to have both the x and y values match, but as you see, it happened this time, and every once in a while it does. The next x value is 0, so we'll fill in the x value of 0. That means we have y is equal to 2/3 times 0, subtract 1. 2/3 times 0, of course, is 0. 0 subtract 1 gives negative 1. So the next ordered pair is 0, negative 1. Our next number is 3 for x. So we'll fill in 3 in the equation, y equals 2/3 times 3, subtract 1, which gives y equals 2 subtract 1, which is 1. And so we have the ordered pair 3, 1.